Welcome to the Decent Crypto Podcast. Today is October 11th, and we are here to talk about BitVM. Matt, how you doing?
BitVM, baby. I am so excited.
I was going to lead
So
with, now that all of our listeners have left, how are you doing? But,
even better,
well,
no pressure now.
yeah,
Um,
exactly.
okay, this is an interesting one because when you Google BitVM or like try to find like a podcast talking about it or like YouTube videos talking about it, a lot of what you see is BitVM. Is this the Ethereum killer? um, and gosh, we haven't had that as like a meta for a long time. I mean, Ethereum killer has that's real throwback vibes, right? But
Yeah,
that is
I
how the
mean,
Bitcoin community is casting it.
first of all, that is not
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 bullish.
accurate at all. Yeah, not bullish. Not bullish, not accurate at all. And Ethereum itself is not really seeing activity to speak of on its own. So
Yeah, killing Ethereum this last week has not been exactly killing it.
yeah,
It's
Ethereum's
what
been killed multiple times the past few days. Um,
I mean,
Ethereum,
people are calling it the on-chain drought. Have you seen
yeah,
this?
yeah, the on-chain winter, yeah, and the on-chain drought. Um, not great times.
um, anyway, let's see if we can kill it again. So, BitVM. Why does this exist, right? So Bitcoin is implemented in a scripting with a scripting language that's like not Turing complete, right? So you can have little checks here and there. You can have little pieces of logic. For example, if you want to implement a multi-sig, right? You can have little pieces of logic that you strap together. So this hash is valid and that hash is valid, then send the Bitcoin, right? Or if this hash is valid and that hash is invalid, send the Bitcoin. Or like if two of three of these are valid, send the Bitcoin, right? Um, you can have little scripts like that, right? But you can't actually build something what's called Turing complete. Um, I guess this is as good a time as any, honestly, to be like, do you know like let's talk a little bit about the notion of Turing completeness. So a Turing machine is something that can execute arbitrary logic, right? So
Yeah.
if you think about it just uh, as a very simple binary machine, right? So imagine you have like magnetic tape, right? And the magnetic tape is divided up into like cells. So you have like, or like registers, right? So you have
Okay.
a variable at cell 0, a variable at 1, a variable at 2, a variable at 3, etc. And each of these is just like a binary variable. It's a 0 or a 1. And so if you read it using like a magnetic reader, you can detect whether the magnetism is one direction or the other. And
Mm,
that gives you like, a representation of binary logic. Um, so given a like this like magnetic tape, right? You need to implement a certain number of operations. So it can be read, write, move forward, or move backward. And that's how you build your program. So the program is something that executes some logic that reads some of these cells, writes to some of these cells, and moves forward and backward in order to like get to where it needs to be. Um, so imagine you want to have an operation that's like if it reads the first two cells, and if they're both true, then it writes to the third cell true. If they're both false, it writes to the third cell false. If they disagree, it writes false. You can imagine how you would implement that in opcode format, right? It would be like read cell, move forward, read cell, store each of these in memory, right? Then this thing, if this thing and that thing, right, move forward, write cell one. If this thing and not that thing, write cell, move forward, write cell, et cetera, et cetera. So it's kind of like these basic operations, these opcodes represent the sort of like bare bones logic of what is required to have generic logic. So in a sort of logical gate, you can have different setups. You have things like if, you have and, right? Um, if is kind of like a separate thing, but everything is kind of an if statement, right? But you can have and, you can have not, you can have or, you can have NAND, which is like you have two inputs. If they're both, so if A is true and B is false, then it registers true, right? So not and is like and but not, right? So
Yeah, yeah,
if
yeah.
they're both true, the output is false. Everything else is true. The output is true, right? I guess this is not a logical gates podcast, but you and then you have XOR, NOR, etc. So there's all these like very very bare bones logical gates, and basically if you can implement NAND, you can implement any number of like arbitrary logical conditions as a result of that.
I see. Interesting. And
Yeah.
what is it
So
about NAND specifically? Is it just that it covers every base of every kind of, or like every combination? Not every
uh,
combination, I guess. So, like, yeah, what is it about NAND specifically that kind of makes it that way?
it's just like it's something that so NAND and NOR both have this property of like you can assemble enough of them in a row to represent whatever arbitrary logic you want, right? So, for example, if all you have is AND gates, you can only ever get more AND gates. So an AND gate is like the inputs A and B both need to be true in order to register true. Anything else will register false. So if A and B are true, the output is true. But that's like so it's an AND gate, right? So A and B. But if A is true and B is false, then the AND gate registers to false because it's not both of them being true. Um, well, you can't build a NOT gate or a NOR gate from that, right? All you can get from AND gates is more AND gates. So imagine we have A
Yeah,
and
yeah.
B and then AND gate, and then we have the output of that feeding into an AND gate, right, from like C and D, right? All you can do is check ANDs there. So
Mm,
the sort of like the special thing about the NAND gate is it allows for like negation as well as like the requirement of like both things being true. And so it's more flexible logically. So you can assemble, an arbitrary number of these to represent whatever sort of logical, check you need to put in place. Um, so from NAND gates, you can have I need A and B to be true and one or both of C and D to be true in order to register true. Otherwise, everything else will be false. And given a certain number of NAND gates, you can create that like arbitrary set of logic. Um, and this is really like very bare bones like Boolean logic, right? Where it's all about trues, falses, ones, zeros, and what kinds of like logical conditions you can build from which kinds of logical operations. And originally, these were built in physical form, right?
right,
So you
right.
would have like a semiconductor that like based on the input of your, say you have an AND gate, right? It has two inputs, like physical metal things. If they both register true, then the conductor flips on, it conducts electricity and the current passes through. And that's how you know that like that both conditions were met. Um, with an OR gate, you can imagine you have like slightly different pieces of metal, and it's like this one, and then at some point the wires cross, and they implement OR using like physical metal, right?
Yeah, yeah,
So these things were initially they were like physical gates. And if you look today, you get like this kind of thing etched into like a teeny tiny like microchip, right? And the speed and efficiency at which like your computer runs is determined by how closely you can pack these logical gates onto the silicon chip. So that's initially each of these things would sit as its own component, right? You would have a gate here feeding into this gate, feeding into this gate. You would hardwire whatever circuit, right? Um, and eventually we realized that you could actually just etch these logical flows directly into semiconductor material. And that's called an integrated circuit because the circuit sits on one integrated piece of silicon, and that's much more efficient. And then as the years have gone by, we've been able to pack these logical operators closer and closer to the point where now, they're like 3, nanometers or something, I think is the latest like distance between two operators on a chip. And literally we're approaching the limits of the laws of physics, right? Where like we're using lasers to etch these things on, and the laser, we can't actually create like a photon beam that's that much smaller. So
Interesting. Yeah, we. I was reading that we basically kind of reached the end of Moore's law for semiconductors, right?
yeah, it's going to require some kind of like either chemical or physical breakthrough in order to get more out of packing the transistors more closely onto the chips. Um, where Moore's law is still very much in full effect is like on like parallelism and optimizing software to take advantage of parallelism. So like GPUs operate a lot of stuff in parallel. They're not necessarily like improving it like 2x the way that like CPUs used to, but there's still a lot of unlocks from software there. And I think with zero knowledge proofs, we see that as well, where like the zero knowledge proof software is getting so much more efficient every year that there really is a Moore's law like effect going in place there. And I think it's something that a lot of people don't necessarily notice. Um,
So there's like a couple things there before we move away from this kind of semiconductor talk. So the first is, what exactly is parallelism in a hardware sense? I know parallelism is like a very popular thing in a blockchain format for I don't know if it's specifically for consensus, but it's kind of some piece of the actual block production where that's how you're processing transactions in a kind of parallel format. Um, then, like, how is that related in a hardware context, or like what exactly are you referring to?
So if you think about parallelism in blockchain, I think the clearest example is Solana, right?
Mhm.
Where
Yeah,
when you send a
that's like
transaction,
parallel transaction processing. Yeah.
you specify which parts of the chain you need to touch, and then the computers that are updating the state of the chain can actually in parallel they can update the state for lots of transactions at a given time as long as they don't touch the same part of the chain. Um, For CPUs and GPUs, the parallelism is somewhat similar, where it's the same notion of like having multiple inputs and potentially multiple outputs, right? And CPUs have this implemented in one way, and GPUs have it implemented in a much like higher throughput way. But it's the same idea of just like being able to process multiple operations using the same like hardware, right? Or that you can have multiple pieces of hardware feeding into the same sort of like collection of like the output data. Um, it's probably well beyond the the interest of our listeners.
Yeah, yeah. No, just curious there. Okay.
This is all to say that like if you look at like bring it all back to Bitcoin. If you look at Bitcoin, there's not a sufficiently generalized like NAND gate setup in the instruction set to start, right? And so you actually are unable to implement arbitrary logic. There are certain logical flows that you just can't implement on Bitcoin because it's not Turing complete. Bitcoin itself does not fit the definition of this like Turing complete machine. The way that like literally a simple piece of magnetic tape that has move forward, move backward, write a one, write a zero, read a one, read a zero. That in and of itself actually is Turing complete if you had a big enough tape and a fast enough moving forward and backward, you could implement
Yeah.
anything on that, right?
Okay.
But Bitcoin doesn't have that. It actually does. It lacks like certain like core components that are required for arbitrary logical expression. Um, and people feel different ways about this, right?
Yeah. So
Like
is there kind of a fundamental reason why this is the case? It was created this way from the beginning, or like why exactly is it not Turing complete? Like why can it not be made Turing complete? Kind of at the base layer. Is there not like an easy way to do that via hard fork? Or I'm sure there is via hard fork, but
Yeah,
Yeah, like
there definitely
why
is via a hard fork.
yeah.
There's always an easy way to do. You can do whatever you want via a hard fork.
Yeah.
Um, the
Uh,
thing is, like, the Bitcoin script is, I think, limited partially by design, right? And partially just by history. So when Bitcoin was built, it was all about just like, can we ship a ledger that's decentralized in a way that game theory dictates that consensus will be met, right? Can we have this decentralized ledger? Uh, and so as a result, like, the number of things you have to consider with like a Turing complete virtual machine, like, you just have to think a lot more about what are the ways that consensus could be attacked, right? What are the ways that like someone could submit a transaction that would fuck with my ability to reach consensus? And so you wind up with a lot more surface area for attacks, right? A lot more attack vectors. Um, with Ethereum, part of the way that they've approached this is through gas. So there's this like fundamental issue in computer science that when you start executing a program, there's no way to know how long it will take to finish without actually running the program, right? There's no way to like simulate like a program in using less compute than it will take to just actually run it. In order to know what the result of running a computation would be, you have to actually run that computation. That's the most efficient way to do it. It's the only way to do it. So so with Ethereum, they use gas, right? So when you sign a transaction, you set a gas limit and you say the maximum amount of compute that should be able to happen as a result of this transaction is X, and I will give you this much gas. And if you run out of gas, the transaction is reverted, but your gas is still spent because the logic has to be executed even though it doesn't change the state of the chain. All the computers in the network still have to execute the logical operations, right? And so you've sort of spent that resource already. This is why reverted transactions cost gas. Um,
yeah.
and
Okay,
so
that makes sense.
so
Yeah,
as
yeah.
you step through the logic, an if statement costs you a certain amount of gas. Assigning a variable costs you a certain amount of gas. Everything is just very like gas built, and the gas schedules have been like altered, and like, over time, like, we've noticed areas where like a certain operation should have cost more and it was not being charged sufficiently, and so someone was like attacking the network that way, right? And so Ethereum's approach has been like, we can figure this out given like a proper gas scheduling for computational complexity. We can make sure that nobody's able to submit a transaction that's, just say running in a loop forever, that's going to like throw the entire system.
Yeah,
um,
yeah. Okay.
with Bitcoin, the approach has been something more like, it works. We haven't had an issue. Let's not fucking touch it. Right? Like, this is serious business. This is not like experimental the way that Ethereum is. This is like really, really like hardened stuff. And it's the same thing we saw with big blocks, right? Like, the Bitcoin community is concerned that once you open Pandora's box and you add in new operational codes, that opcodes that would allow you to reach Turing complexity or Turing completeness, right? You you would wind up like introducing attack vectors, and like, once, where do you stop? It's a slippery slope,
Right,
right?
right.
And all the usual anti-innovation stuff. It's complicated and political, and even within the Bitcoin community, people feel lots of different ways about this sort of thing, right? And so we wind up in this weird space where people want to implement as much interesting logical complexity as they can on top of Bitcoin without changing underlying Bitcoin itself, because they've assumed that to just be impossible, right?
Okay, so which pieces, when you say like without changing underlying Bitcoin itself, like which pieces are you actually talking about? Like what about Bitcoin would have to change for it to be kind of for it to allow a Turing complete language to run on it, or kind of like what exactly would you have to change that would I don't know require you know whatever kind of effort that is deemed not possible, or do
So
they say it's more on a technical level that people assume that it's not possible?
It's like there are a certain number of opcodes in the Bitcoin scripting language, and they don't cover the full spectrum of what you need for Turing completeness. Um, and so you would need to have a hard fork that added opcodes in order to allow for that. Um, to give you some idea of what would be possible, right? You could have a zero knowledge proof like roll up on top of Bitcoin if you were willing to have enough opcodes to implement the verifier on the L1. But the opcodes are just not flexible enough to implement a ZK proof verifier today. And so there's no way to have like a safe like ZKL2, right? Um,
Hmm.
it's just that the number of opcodes is not enough. Like there are some that need to be added, and they're contentious, right? And
Yeah, yeah,
people come along and propose them all the time, but the community just doesn't seem to, which just doesn't feel like the people that run miners or full nodes or users, wallet providers, whatever. It doesn't feel like they want to support that kind of fork. Um,
yeah.
Bitcoin
I
is what
don't
it
think
is.
like
It does what it
yeah,
does. That's what it's supposed to do. And if you don't like it, like
that
great,
kind of hard
enjoy.
fork seems extremely unlikely.
Yeah. Um, and so we wind up in this weird state of the world where if people want to use Bitcoin for other stuff, they have to either trust a centralized third party and use like wrapped Bitcoin offered by like BitGo, right? Um, or they have to like transfer their Bitcoin to a centralized third party, like a lending platform, and like BlockFi back in the day, right? And then you can use it as collateral,
Yeah,
borrow
rest in
against
peace.
it, RIP.
Yeah, yeah.
um, and uh, and Bitcoiners probably point to a lot of this and say like, look, like this is just all the more validation that like we shouldn't fuck with it, right? Like we really shouldn't have too much more operational complexity happening on Bitcoin. There is more. So Bitcoin is slow, right? It's not a good EV, or it's not a good like Turing complete virtual machine. You have new blocks every 10 minutes, right? You reach consensus and finalization, happens in like an hour,
Hmm.
roughly speaking. Uh,
Yeah. Yeah, and
and
just that's because you want six confirmations in general
yeah,
before you come to finality. Um,
it's slow. Imagine I have a borrow or a lend, like I'm borrowing some whatever against my Bitcoin, and the value of my collateral drops, and I want to repay it before I get liquidated. And the last block just happened. I have to wait 10 minutes, and prices can move a lot in the meantime. It's not a great backbone for a lot of this stuff, right?
yeah.
Bitcoin is great at what it does and really, really not great at everything else.
So, I mean, this kind of brings us back to the essential question, which we asked at the beginning, which is like, why does this exist? Like, coming back to BitVM, right? Like, you can really look at most activity on Bitcoin, and it's really just some kind of financial settlement. Now, obviously, there's ordinals, so a lot of transactions are happening with ordinals, and that's a whole separate thing. But with kind of Turing completeness, I guess you could say, or bringing like EVM type functionality to Bitcoin. It's like, why exactly would you really even want this? Um, is it something people want?
So people want more functionality on top of Bitcoin for a couple of reasons, right? The first is this notion of like it's the most hardened blockchain, right? Like we lament all we want about how it's hard to change Bitcoin, it's hard to add, opcodes or whatever, but there's a reason for that, right? Like the sort of ossification, like which is like turning to bone, right, of the protocol, is a feature, not a bug. And you know how Bitcoin works, you know how it works today, you know how it'll work tomorrow. And, up until quantum compute becomes like really good, Bitcoin will probably continue to operate roughly the same way forever. And then
Yeah,
we'll probably change it once for quantum, and that's that. So it's this notion of like security, safety, you know what you're getting in a way that like something like Ethereum, proof of stake, and EIPs and gosh, this thing is changing constantly. Or Solana, been in mainnet beta for 4 years, right? um, like those are not secure the way that Bitcoin is, right? With Bitcoin, you know what you're
Yeah.
getting. The second thing is that Bitcoin is the biggest source of capital or the biggest capital pool in all of crypto. It's the biggest crypto asset, and there's a huge amount of like liquidity or TVL on Bitcoin. The TVL on the Bitcoin blockchain is the market cap of Bitcoin, which is massive. Um, if you could unlock that for use in DeFi or use in NFTs, it's the same thing as ordinals, right? Like just being able to have that flexibility of taking a loan against my Bitcoin on the Bitcoin blockchain without having to trust a third
Hmm.
party would be
Yeah.
nice. Um, so I think that's kind of the idea is like,
Mm.
you know what you're getting. It's really solid and you know you don't have to worry about it. And so it would be nice to have more functionality on that, right? And not
Yeah.
take
Yeah.
like all of the compromises you get with something like Ethereum or Solana.
Mm. And so, like, you're thinking very basic stuff, like basic lend and borrow, maybe basic kind of stablecoin issuance as well. Um, Stuff that does not require really advanced either compute or kind of time sensitive transactions either. Stuff
Yeah,
like that.
yeah, I think it can't be too time sensitive. And well, I don't know. Why don't we jump into BitVM and then we'll explore a little bit of
Yeah,
what's
okay,
possible.
yeah, let's talk about what BitVM is.
So BitVM is a pretty straightforward proposal for like protocol building that works on Bitcoin today and enables some notion of Turing completeness. So um, basically the way it works is with BitVM, two parties deposit their Bitcoin into like an account, right? That has like a taproot script associated with it. So this is a bit like a lightning channel, right? You have two
Hmm.
parties sending Bitcoin to one address. Um, and the way that the logic of the address works is basically like lightning. So given a certain set of conditions, it'll send all the Bitcoin to you. Given a certain set of conditions, it'll send all the Bitcoin to me. And you can update variables in the script that determines those conditions one at a time, basically, bit by bit. Um, so, um, so the way the white paper works is they basically show you here's how you could implement a one or a zero, right? And when you submit when you open this channel, you have two hashes that you submit. Hash one is like it will set the variable equal to one, and hash zero will set the variable equal to zero. And you reveal the data that gets hashed to determine those hashes, depending on which one you want to reveal. So, say we
Mm,
want to set this variable to zero, we would reveal, they call it like a pre image zero. And that's the data that gets hashed to go to the hash zero. And that sets this variable to zero. Um, and using that sort of like bit setting, you can basically implement a NAND gate, which then from there, if you stack infinite of them on top of each other, you can implement arbitrary logic, is the idea.
mm.
Um,
Okay, got it, got it.
and it works a lot like Lightning, where one party will provide like the pre-image that hashes to whatever, and they'll say, "I'm setting this to a zero." And then the other party gets a chance to respond and be like, absolutely not. I have a signed transaction from you that hashes to this other hash that says this is a one. And basically, if you ever lie, all the Bitcoin that you put in up front gets given to the other recipient. So you have like, it's kind of like fraud proofs, right? With optimistic rollups.
Mm, okay.
Um,
But it still works via state channels, and so it's still going to kind of require a ton of liquidity to be bootstrapped and to kind of get these channels to actually have links between them. So, people don't have to all be connected directly. I mean,
uh,
it's gonna have
yeah.
to be it's gonna have to like start up the same way as the Lightning Network, right?
Yeah, that's definitely one limitation, right? The primary limitation on this is it's a two-party system. But the secondary limitation, and this is just as bad, is if there is fraud, you have to like submit that proof, and that can require posting a lot of data on chain, literally bit by bit, to prove that like one bit was not computed correctly by the other party. Um, and that can lead to like an issue where, for example, you might not be able to get your transaction through in time, and the other person is able to commit fraud. Or like
Mm,
you might need to commit, you might need to send so many transactions that like the gas fees are not worth it to get your Bitcoin out. And
mm,
so the level of inefficiency is just like staggering, right? You're literally going bit by bit, revealing the pre-hash like data that hashes to whatever output that sets the variable to a one or a zero. This is really, really low level stuff. Um, and it all requires taproot scripts to work, right? If both parties cooperate, this can work without like much data being posted to the chain. One person just posts like this is the output of like all of the logic that happened, right? Um, but as soon as both parties don't cooperate, it becomes a total clusterfuck of like data getting posted to the chain. People posting a pre-image, and then someone else posting like a fraud proof of that pre-image again and again. And depending on the number of like zeros and ones you want to have in this thing as variables, like it can get out of hand pretty quickly. Um,
mm.
and so it's not really feasible as a production protocol, right? But if you really needed to, you could have some kind of arbitrary logic here that wasn't available to you outside of within like
Yeah, I
the
see.
existing Bitcoin script.
Okay.
um, so that's
Yeah.
sort of the idea here
I'm
is
just trying to conceptualize like what kind of functionality does that actually unlock for you? Um, like the
it's
NAND.
not much, right? It's like
Yeah. Like what exactly is as a NAND kind of like gonna let you do basically?
so let's say that you and I enter into a bet, right? That the I don't know, like the Eagles are going to win their game this week, right?
Mm-hmm.
Fly Eagles fly. Um,
Mm-hmm.
we each put one Bitcoin in, right? And
Yeah.
then we have like a third party like Oracle, right?
Okay.
And in order to unlock the assets, we need one or both of us to sign the transaction that says that like if like let's say we both are nice and we agree and we're like, yeah, the Eagles won, you get to take my Bitcoin. We sign the transaction and then the Bitcoin gets sent to you, right? If we have some kind of arbitration, maybe we need a signature from the Oracle provider that also says like, look, the Eagles won, so no matter what, like say I'm refusing to sign it, right? We need a signature from you and a signature from the Oracle, and that will release the Bitcoin to you. So
Mm.
it's like we need either you or me, or we need either you or me or the Oracle to sign, but not just you or just me or just the Oracle, right?
Yeah, okay.
It is kind of a 2 out of 3 multi-sig, right? But let's say the Oracle wants to serve multiple of these like betting, channels at the same time. They don't have to sign something that's specific for our channel. They can just sign a message that hashes to something that we set out at the start means that the Eagles won, right? So when we create this channel, we have like a variable in our script that refers to Eagles winning versus Eagles losing, and we know ahead of time like what the output, what the signed transaction will look like from the Oracle. Or at least we know some component of it, and we can
Mm.
set that up in our script. Um, and so that way, multiple people can use the same script without having to like submit the transaction on behalf of this like Oracle party. That's
Mm.
like one option. The problem with borrow lend, the problem with DeFi, the problem with broader use cases on Bitcoin is that there is no stablecoin right now, right? Uh,
Yeah.
and nobody wants to spend their Bitcoin, right? And to me, that's the bigger issue, right? And does this allow for stablecoins? Kind of, but not
Yeah, so that's a
really.
Okay. So you don't think like using this you could have some kind of stablecoin issuance with like I don't know, a bunch of stablecoins locked in a multi-sig that of course are, you know, the deposits go through some kind of centralized party, but then the unlocks happen through, you know, some kind of multi-sig where like you put in that stablecoin back that lets you actually withdraw dollars. I don't know, some kind of format like that. Um, because
Yeah,
yeah, to
I
me,
mean,
it's like stable coins are the core of all of this. If you don't have stable coins, or even if you have stable coins that are trusted in some way that's like even like I don't know, like
like
even Tether,
USDC.
I don't know. Yeah, yeah, like USDC, right? Like if you had USDC or something like that on this chain, I still don't think it would really work because of how like what the user base, like what the coin or what the Bitcoin people are like, and what
Yeah,
just this product represents as well. It's yeah, all about
yeah,
kind of keeping everything on chain. So I don't know if a centralized stablecoin would really work. So yeah, I don't know. Like maybe it would really be cool if you could have something that's like native, like
like DAI.
Dai. Yeah,
Yeah,
that would
I just
be
think if you
really
walk,
cool.
well, if you walk through it, right, you and I set up some DAI, circuit that based on the amount of Bitcoin and some signature from an Oracle provider on the price of Bitcoin allows for a DAI balance variable to get set somewhere in this, like, the whole thing is just like one big circuit, right? When you write a program for like BitVM. So say we have that set up. The problem is that like I can't move that DAI, right? Um, like there's nothing I can do with my bit die. And so it almost winds up being kind of meaningless because there's no opportunity for third parties to like join in here without adjusting something in the Bitcoin like consensus scripting, right? So this is the thing about ordinals and like BRC20s. The native Bitcoin protocol itself is never recognizing any of that, right? All it's doing is like, there's some data here. I don't know what the fuck it means. Someone else has to like interpret that, right? You have to run a node that looks at that data and decides how it's going to interpret it and use it and act as a result.
Mm, yeah,
It's the same thing here, right? So the nice thing here is that like all of the logic itself actually is like known by the nodes in the Bitcoin network, right? Because it's part of like the protocol by default. But the actual like notion of like a non-Bitcoin asset is not something that can get coded into Bitcoin, right? And so you can't really have a transfer or whatever. And so it's like it's kind of just a toy, right? On its own. There
yeah,
isn't really like without having that ability for like multiple people to interact or like the assets or logic, contained in one circuit to interact with logic contained in another circuit, it doesn't really work. And that's why I'm bearish on BitVM.
yeah. Same here. I think it's a cool concept. I think there are quite a few limitations. So, let's pull up some while we're on the most important part, which is bullish or bearish. Let's pull up a little bit more FUD on this topic. Dan Robinson of Paradigm says this is getting way too much attention in the Bitcoin world. The protocol only works for two parties, so it can't be used in rollups or other multi-party applications. And Greg Maxwell proposed a much better protocol (parentheses ZK contingent payments) to solve the same problem 12 years ago. Um, so yeah, I mean, I do think that it's an interesting proposal. I think it's cool. I think the more that we have to do on the chain, I think it's it's just not positive, but I do expect that actual usage will be pretty low, especially like the fact that you have to have this kind of channel architecture still. I think it's just going to be so hard to bootstrap any kind of liquidity that it'll be pretty tough.
Yeah, I mean, it's interesting, right? Because effectively, the channel architecture is an optimistic rollup with two parties. and that's really really challenging. And rollups in the ETH world have the same issue of like if you don't attract that core liquidity at the start, it's really hard to bootstrap your ecosystem. um,
Mm. So this is basically an optimistic roll up with two parties, meaning that you have to have a new roll up every single time with each
yeah,
party, or like how does that
yeah.
work?
Yeah, I mean, it's basically like, so look, at the end of the day, if say we don't agree or there's fraud proof or whatever, like the default is to send Bitcoin to one person, one address, or to another. And
Mm,
that's the way that like ultimately any of this is enforced. It's all about like where does the Bitcoin get sent eventually? It's just like the Lightning Network, right?
mhm.
Like
Yeah,
this is
yeah, yeah.
very, very similar to the Lightning Network, except with like more programmability around the conditions that lead to whatever outcome,
Mm,
rather than just like I sent you some, you sent me some, whatever. But honestly, like without that multi-party ability or multiple assets on the same chain or whatever, like this just doesn't lead to any more interesting use cases than Lightning has out of the box. It's the same problem with this like ZK contingent payments thing. That's basically Lightning, right? And contingent payments based on like a proof, like what is the most like simple proof? It's a signature that I sent you some Bitcoin, right?
mm,
Like that is basically a ZK proof. It reveals to you exactly what you need to know and nothing more. That like I
mm.
sent you some Bitcoin, and then you have another transaction that you sent me some Bitcoin, and that's basically zero knowledge like payments on Bitcoin.
Yeah,
It's
yeah.
just transactions, right? Um,
Mm.
and so the core innovation of Lightning or any of this is that like ability to challenge. So you have the time lock, and then you can challenge like if someone tries to commit some fraud and claim Bitcoin that's not theirs. There's a period of time when the other person can come in and prove that like that's not the valid like most up to date state of the world, and they submit that, and then so it is like an optimistic rollup, but it's an optimistic rollup that all it can handle is bidirectional payments.
Mm.
um, so
Yeah,
yeah,
yeah, interesting, but not gonna work.
yeah, you know, it's a beautiful vision, right?
Mm,
Like, if we had a ZK rollup that, here's a good question. If we had a ZK rollup that actually worked on top of Bitcoin, just like a ZK rollup on top of Ethereum today, do you think it would get usage? Do you think it would attract builders? Like, is that bullish or bearish? Say a new Turing complete ZK rollup, like say it's really good and it's implemented in fucking Solidity, right?
mhm.
What do you think?
On Bitcoin?
Yeah.
I think it's just tough because the rest of the ecosystem is not there, right? Like I think you need like stable coins. I think you need like borrow land, you need swaps, you need like activity through shit coins, you need liquidity moving around all over the place. So I think it's tough because all of that is just not in place. And if you don't have that, you're just kind of bootstrapping everything all at once.
Hmm.
And so that is, I think people would still build on it. I do think it would get some initial traction, maybe, but I think it would be tough to have something really to the size of what exists on Ethereum now.
Okay. A slight rephrasing then. Say we had it and Circle joined. Do you think people would use it, or would they use Ethereum?
Mm. Oh, you're saying as an either or. I think initially still Ethereum just because of the network effect, but I think eventually maybe you have more people using the Bitcoin kind of ecosystem. I think you could maybe see like a I don't know, like a world where the Bitcoin usage is like at least 30%.
Hmm.
Yeah.
Interesting. Yeah, it is interesting, right? Because settlement is so much more final on Bitcoin,
Mm-hmm.
arguably, right? But to a degree, it's also not, right? Like it only, Bitcoin has good and bad things about proof of work, right? Like it's very expensive to change the chain, but it's always possible. Whereas with Ether, it's also very expensive to change the chain, and after like a certain number of blocks, it's just not built into the protocol that those blocks can be changed anymore.
Mm. Yeah, yeah,
Um,
exactly. I mean, I don't know. I think for like again, it really becomes use case specific as well, where it's like settlements or like very kind of long term, very low risk kind of lending. I can see actually a lot of that activity going to Bitcoin if there's secure ways to do it. Um,
yeah, I guess the biggest use case would be borrowing against your Bitcoin, right?
yeah, exactly.
Yeah,
But yeah, again, like you probably want to borrow some kind of stable coin rather than Bitcoin.
yeah,
Um, so yeah.
yeah. It's interesting.
I do think like yeah, having some kind of native lending. But again, like with native lending, it's like you need the native stable coin. So like, how do you solve some kind of native stable coin um, problem without running into then well like yeah decentralized stablecoin is very hard without having smart contracts. You can have some kind of centralized stablecoin, but how much do you really trust that? And then yeah, you're moving into a whole different world.
Yeah, I do think the biggest challenge with the decentralized one is the block time, right?
Yeah, definitely. And to kind of have like a stable coin built around block times that are that slow, I think is also tough.
Yeah, yeah, yeah. Interesting.
Hmm. All right.
All
Well, I
right,
guess we're both
BitVM.
bearish.
Yeah, bearish.
BitVM, good
Time to
attempt.
send. Yeah, watch BitVM unlock
Yeah, I
everything.
know. What BitVM is like the greatest thing since
Mhm.
sliced bread. Okay, Matt, you got anything else?
No, yeah, let's wrap it. Let's record a recap next time in a few
Yeah,
days.
definitely.
Cool.
All right. Well, thanks for listening, everybody. This has been the Decent Crypto Podcast on BitVM. We'll be back in a few days with everything that happened this week. And until next time, stay decent.